Hello and welcome to the third video on section 1.8, continuity. This video covers a special property of continuous functions known as the intermediate value theorem. Take, for example, a person's height related as a function of time. Barring a tragedy, as a person ages, we would describe their height as continuous. That is, there is a constant flow. If I was 3 feet tall at age 3 and 6 feet tall at age 28, then you would expect that there is an age between 3 and 28 where I was 4 feet tall. In fact, you'd expect that there would be an age between 3 and 28 where I was any height between 3 and 6 feet. Attaining these intermediate values is exactly what the intermediate value theorem guarantees. Given a continuous function f on the interval ab, since continuity has a constant flow, if we take any y value n between f of a and f of b, then we expect to find an x value c between a and b, where f of c is equal to n. That is to say, because a function is continuous, you would expect all intermediate values to be attained. This is a fundamental property of continuity. By dropping continuity, many examples would contradict the conclusion of the intermediate value theorem. Take, for example, hair length. Most people get haircuts, which would add a jump discontinuity to the relationship between hair length and time. Say at time A, my hair is 9 inches long, and at time B, I get a haircut and my hair is 3 inches long. Because a haircut introduces a jump discontinuity, there is no guarantee that my hair was ever 5 inches long between time A and B. The barber could have cut from 9 inches to 5, then down to 3, but the point is that without continuity, there is no guarantee of intermediate values. The intermediate value theorem can be used in many ways. The most accessible example would be to locate intervals for which we are sure a root of a function exists. How would we go about finding roots, or zeros, of this polynomial? Well, we know that polynomials are continuous for all values, so with the intermediate value theorem, we can try and find x values whose y values switch from positive to negative. Take, for example, the x values -1, 0, 1, and 2. We look to these y values to see if there's a change from positive to negative. Between x equals 1 and x equals 2, the y value switches from -1 to 12. On this interval, the intermediate value theorem guarantees us a root. Since 0 is in between -1 and 12, and f is continuous, there exists a value c in between 1 and 2, where f of c is equal to 0.